All right, you guys, here I'm taking on, this is homework 48, problem 7. So the first thing that I'm going to do is label all of the parts. And I just took the time to draw my picture a little bit bigger so that I could label everything and see it very clearly. So I know that AB is 12. I know that BC is 8. I know that DE is 6. And I know that PD is 4. So I also am told that A is a point of tangency, and we're calling it circle P, so P is the center. We want ultimately to find a radius. And I have no radii marked in the diagram at this point, right? Because a radius would be connecting point P to any point on the circle. So first I'm looking at my picture and I'm just thinking, is there something else I can solve for to help me out? And I can see, oh, right here, I can solve for CD. So let's start with that. Let's call CD X. So what I can see right now, let me just strip it down even more. Here is my circle. Here is that tangent segment. Here is that secant segment. So here is 12. This is 8. This whole span from here to here is x plus 6. So then this whole part is x plus 14. So I know that I have a tangent and a secant relationship, and I know that a tangent squared is equal to the whole times the outside for the secant segment. So here I would have 12 squared equals the whole, which would be x plus 14, times the outside, which is 8. So now I have 144 is equal to, let me distribute the 8, 8x plus 112. Okay, subtract the 112. Now I have 32 equals 8x, divide by 8, and I get that x is 4. So I can fill in this gap right here that CD has a measure of 4. And now I need to look at my diagram and think, well, what else can I do to get to a radius? What else could I draw in to make a radius? Well, I could connect P to E, but I don't have a right angle here, right? Because this chord is not being bisected. So that's not going to help me much because I don't have an angle measure to build off of. So I need to think, is there another way that I could draw in a radius? And I actually see, stripped down, I can see the segments that are going to get me there. So let me redraw my circle. Okay, what I'm going to do, here's P. I'm going to draw in that segment to where D is, but I'm just going to elongate it. And then I'm going to draw in this chord, kind of like that, and label what I have right now. So I have the 4 here, I have the 6 here, I have the 4 here, and I'm going to go ahead and connect all the way through like that and draw in a diameter. So let's say that I'm solving for this part here. I'm going to call that y. Then I can see that a radius will be 4 plus y. So radius will be 4 plus y. So right here, this is a radius. That will be 4 plus y, or y plus 4. All right, y plus 4. Same thing. Okay, so now I see, oh, I actually have 2 chords. So if I'm picturing how I'm going to set this up, I know that I'm focusing on that point of intersection right here. So I know that 6 times 4, so I'm saying this part times this part. So 6 times 4 will be equal to, I need to know what this part is times this part here. So here I'm saying, well, that's y plus 8 times y. So I know that when my chords are intersecting inside of a circle, I'm doing the product here equal to the product here. So now I'm ready to continue on and solve for y. But keep in mind, my radius is going to be 4 plus whatever y is. So I have 24 is equal to y squared plus 8y. Okay, so now I see it's a quadratic equation. Let me pull that 24 over to the other side and see what I can do. So 0 equals y squared plus 8y minus 24. Okay, so here I run through my options. Can I solve by taking the square root? No, can't solve by taking the square root. Can I solve by factoring? Can I think of two numbers that multiply to a negative 24 that add to 8? No, I can't. Okay. So my choices here are quadratic formula or solving by completing the square. We have not practiced completing the square for a while, so let's do that. So when I'm solving by completing the square, I like to have my variable on the same side and my constant on the other side. So I'm going to move that 24 back. Move it back to the other side. So I'm going to rewrite my equation also with the y values on the left. So y squared plus 8y equals 24. So when I'm solving by completing the square, I want to split that linear term in half and square it. So 8 split in half is going to be 4. Square it, I get 16. So I have y squared plus 8y plus 16 equals 24 plus 16. Okay, so what I do to one side, I have to do to the other. And the whole point of doing that was to create a perfect square trinomial that factors into a binomial squared. So y plus 4 as a quantity squared equals, over here, 40. And now I can solve by taking the square root of each side. So y plus 4 is going to equal plus or minus. 40 is 4 times 10. So 2 root 10, and then take away the 4. So y equals negative 4 plus or minus 2 root 10. But y can't be negative, so I'm only interested in the positive. So negative 4 plus 2 root 10. So that's what y is. But remember what my radius is. My radius was y plus 4. So I'm taking this negative 4 plus 2 root 10, and then I'm adding 4, which these two opposite numbers then will just combine to 0. So my answer ends up being 2 root 10. So definitely a bit of a challenge problem, which is why I made them optional. So this problem was optional. Hopefully you could get there, just challenge yourself and get to that 2 root 10. All right, have a good rest of your day.